Good morning, friend. How are you? I hope you are keeping safe. You're welcome to today's mathematics class. And based on your demand, I want to treat with us today what we call angle of elevation and depression. Angle of elevation and depression is a topic in mathematics that will keep recurring even till you get out of secondary school. In senior secondary school is a major topic. Now, what are the objectives of this study? What are those things that you must be able to do at the end of this short lesson? You must, number one, you must understand the simple practical meaning of angles of elevation and depression, as simple as ABC. You must be able to understand the practical meaning of it, because it's not rocket science. It's what happens daily in daily life. Number two, you must be able to comprehend and translate written problems involving the angles of elevation and depression into simple sketches, diagrams, rough sketches on paper, easily and on your own. And number three, you must be able to solve various questions drawn from this particular topic, successfully and independently. By way of introduction, what do we mean by angles of elevation and depression? I said here, the angle of elevation and depression are two common terms that occur frequently in the application of trigonometrical ratios. You know what this means? Trigonometrical ratios mean your SOHCAHTOA. What does that mean? Your sine signifying opposite over hypotenuse in a right angle triangle. Your cosine, or the short form is cos, signifying adjacent side over hypotenuse side in a right angle triangle. And your TOA, the T for tangent, and tangent is equal to opposite side over adjacent side in a right angled triangle. So what we base this angle of elevation and depression upon is all based on a right angled triangle. No matter what you are sketching, the end point will be a right angled triangle that you will solve easily using your SOHCAHTOA. The angles of elevation and depression can be applied and used in calculating the following parameters. That means the application. What can it be used to solve? It can be used to solve the height of an object above the ground. How high or how tall is an object? The number two, it can also be used to find the distance of an object from a given point of observation. I'm here, I'm looking at something above my height, at a particular distance away from my height. That distance of that object to my eyes can be deduced, can be calculated using the angles of elevation and depression. Now, by definition, what do we mean by the angle of elevation? Angle of elevation, I said, can be defined as the angle through which the eye turns upwards from its original horizontal position while viewing an object located above the eye level. Everybody has an horizontal eye level. On a normal ground, on a normal day, I'm supposed to be looking straight. I look straight. Now, if I want to look at any object that is placed above my eye level, I will need to turn my eye level, horizontal level of the eye up and look up like this. So the angle of elevation is the distance, the difference in angle between when I was looking straight before and now when I'm looking up. So it's like something like this. I'm looking straight, this is by my horizontal eye level. I now look up, I turn my eye. Then there's an angle here. This angle at the middle is called the angle of elevation of that object I'm looking at from my eye. I gave an illustration here. Look at this. Let's say these are two friends. This is Olawale and this is Bimbo. I want you to picture the assembly ground and picture that Bimbo is on the assembly ground and Olawale is on the first floor of the school building. Now, for Bimbo to look up, Bimbo normally, this is the normal line of sight of Bimbo on the horizontal if she is not looking up. Now, if she looks up, she will have to take her eye and turn her eye up. And that is why angle of elevation is an angle turned through upwards. And so
she turns the eye up to the level where she could see Olawale at the first floor. So this angle turn through is called the angle of elevation. I said represent this angle. You can represent with any letter. This is a Greek letter called theta. And this theta, I said, is equal to the angle of elevation of Olawale from Bimbo. Bimbo is the one that is receiving the sight. So the sight comes from her. So the angle of elevation of Olawale from Bimbo and not the angle of elevation of Bimbo from Olawale. So when you are talking about angle of elevation, it comes, it will talk about the angle of elevation of an object you are looking at from the point of view or from that person that is looking at it. Line AC here, this line, let's say this is A, where the Bimbo is standing is A, and then this is the point where Olawale is standing C. Then AC will be called the line of sight while looking up, while Bimbo was looking up. Then AB, which is horizontal line, will be called the line of sight while Bimbo is looking straight horizontally before she looks up. Now I go to angle of depression. Angle of depression. And I define this as the angle through which the eye turns downwards from its original horizontal position while viewing objects that are located below the eye level. So angle of depression applies to things that are viewed, things that are located below the normal horizontal eye level. And what does this mean? I give an illustration here. Say this is John looking downward to view Olawale. Olawale is on the assembly ground. John is on the first floor of the school building. Now, John, normally, if standing on the first floor, if he looks straight, this is the normal line of view, horizontal line of view. For John to look down, John will have to bend his eyes down or turn his eyes downwards, and that is why the angle of depression will take a downward movement. And I represent with alpha. Alpha is a Greek letter. Now, this alpha will be equal to theta, the angle theta A. Why? Because alternate angles are equal. Angle theta, you know from residual knowledge that this angle alpha and theta are alternate angles. They are alternate angles. Angles at different ends, opposite ends of a parallel line, with a straight line. That is alternate angle. So you make use of alternate angle mostly when you are dealing with angles of depression and not angles of elevation. So the angle that is here, let's say the angle here is 30 degrees. If John turned his eye through 30 degrees, this 30 degrees will not be used here. It will have to fall down here because it will be alternate angle. So you use the 30 here and you use your trigonometrical ratio that goes along with it, whether it's sine, cosine, or your tangent to get your answer that you are looking for. It is not rocket science. Very, very simple. Now, when we come to talking about worked examples, there are 7 examples in all that we'll do together. 4 of them will be on angles of elevation, and then the other 3 will be on angles of depression. And look at number 1 here. Take a look at number 1. It says the angle of elevation of a point P on a tower from a point Q on the horizontal ground is 60 degrees. You know what they call a tower? A tower is like your mast, your telecommunication mast. A tower is a very, very tall object, very high object. So they are talking from, say this is a tower. If this is a tower, the angle of elevation of a point P on a tower, say this is point P on a tower, the top of the tower, is from a point Q on the horizontal ground is 60 degrees from a point Q on the horizontal ground is 60 degrees. So this is somebody looking from here, and he turned his eye up to look at the point P. The angle he turned it through was 60 degrees according to the question. So if you have 60 degrees here, very simple, and then you are given, they say the distance PQ is 74 meters. So this is Q, these are Q on the horizontal ground. This distance is being given already, 74 meters. You label accordingly. How high is P above the ground? This is point P. I tell you this is the ground, G, represent with G. So the distance we have to look for here to calculate is X. Let's say it's X, distance PQ. That's the height of the tower. How do you go about this? Think of the only two things we are given here is just the 74, the hypotenuse of this right angle triangle, and the angle 60. So the expected or the required side that we're looking for is the X, which is the opposite of the 60 angle 60 degrees. So what do? Pick the one that has opposite and hypotenuse together, and that is your sine is equal to opposite over hypotenuse. So what do? You say sine theta is equal to opposite over hypotenuse, and then your theta here is 60 degrees. Sine 60 degrees is equal to, what is the opposite? X. The side that is facing it, X, all over the hypotenuse is 74. What do you have here? Your X, if you cross multiply, will be equal to 74 multiplied by sine 60.